Good afternoon, class, and welcome to my first flip lesson for the school year. Up to this point, we're going to be talking about primary trig ratios, and you would have done this, so this would be review for pretty much all of you. And up to this point, we've only discussed right angle triangles and the Pythagorean theorem, and we all know that this side is labeled the hypotenuse. And if I put a little symbol here to denote the angle, this little funny symbol is called theta. And with relation to theta, that means this side over here is labeled as the opposite. It's opposite to the angle. And with respect to theta, again, the side closest to it is labeled as the adjacent. Adjacent. Should be no A there, adjacent. And last year, most of you would have been told a mnemonic to remember all the trig ratios, and the mnemonic is SOHCAHTOA. Okay, so this means that the sine of theta is opposite over the hypotenuse. The cos of theta is the adjacent over the hypotenuse, and the tan of theta is equal to the opposite over the adjacent. Okay, so let's go back to this. I just want to tell you where the origins of these relationships come from. So what I've done is drawn this circle, and in math this is referred to as the unit circle. And notice how it has a radius of 5 units. And what I did was I took out a protractor on my toolbar here, and I measured exactly so that theta was 45 degrees. Okay. And that means if this angle is 45 degrees, that means this angle over here also has to be 45 degrees. And as a result, by definition, we end up having an isosceles triangle. That means this length over down here, it looks like it's 4 and a bit, has to be the same length as this distance here. Okay, and if you also notice, if we relate these distances with respect to how the axes are labeled, you know, this distance would be x and this distance would be y. And you know, essentially this is also where the Pythagorean theorem also came from, right? X squared plus y squared equals r squared. Normally this is labeled r, this is the radius. Right? However, they just changed the letters, right? So the letters that we use in the Pythagorean theorem is a squared times b squared equals c squared. Well, essentially, this is where it came from. Okay. So if I use 45 degrees here, and you know, I look at this side over here. So this side over here is the opposite. And this side along the x-axis closest to this angle, you know, is the adjacent. And I've already told you that these two sides are the same length, okay? And from the limerick, or the mnemonic, sorry, we know if I'm going to use opposite and adjacent, you know, I can use tan. So tan 45 degrees is equal to opposite over adjacent. However, I already know that tan 45 degrees, well, I already know that this length and this length have to be the same. That means, you know, if I take one thing that's the same and I divide by the same thing, I'm going to end up with a 1. So, you know, as an experiment, if you have your calculator as you're watching this video, you know, you can do tan 45 and see what you get. And this is how we get all the trig ratios. If I go to a website, so to show you on a website how this works, we'll go to mathisfun.com, and you can see the website in the URL up here. Okay, and let me scroll down a bit. Well, they have this interesting thing already set up as a Java plugin, and if I can drag this, right, and notice how you see the angle changing, and let me get it as close as possible to 45 degrees. Well, here's 45 degrees, Not quite the same, but very, very close in terms of what this length is, 7.01 and 7.12. And so right here we get tan A is equal to 7.12 divided by 0.701, and it's very close to 1, very close to 1. Okay. Now I just want to go through a couple of definitions before we start looking at some examples. The first definition is the angle of elevation. It's the angle between the horizontal of the line of sight. So here's the person's line of sight when looking up at an object. So let's say this particular person's looking up at the sun, right? And here's the line of sight, the horizontal line of sight. This angle over here would be considered the angle of elevation. Conversely, when we look at the angle of depression, it is defined as the angle between the horizontal line of sight. So here's the horizontal line of sight here. When looking down at an object, so here's my makeshift little boat down here. And so the person's looking down. Be careful here, and I've completed the triangle here. The angle of depression is this angle here between the horizontal line of sight and between looking down at the object. So that would mean that this angle over here would be 90 degrees minus whatever the angle of depression is. So you have to be careful. So keep that in mind when solving questions. So let's now look at an example of how to use the trig ratios in solving questions, both for finding angles and for finding side lengths. So the first thing you want to do is, look at where theta is labeled and start labeling the sides in relation to theta. So we know that this is the hypotenuse. And we know that this side, opposite to the angle, is the opposite side. And if it helps you to keep everything straight, you may want to write SOHCAHTOA down on your page at the top, if that helps. So I know that the sine of theta is the relationship of the ratio of the opposite side, 0.88, divided by the hypotenuse, 3.6. Okay. At this point, so in actual fact, in this example, we're looking to find what this angle is. So the next thing you would have to do is we have to use the sine inverse function in order to find the angle. So theta is sine inverse, and in brackets, 0.88 divided by 3.6. Okay. And if you perform this calculation on your calculator, I believe you get around 14 degrees as the angle here. Okay, and again, if there was a person down here, this angle would be the angle of elevation. So for the second example, a little bit different. So now we're given the measure of theta, or we're given the measure of the angle of elevation as 15 degrees. We still have the hypotenuse at 3.6, and now we want to find the height. Okay, so again, we're still using the same trig ratio of sine. So this time it's sine 15 degrees, and it's equal to, remember, it's equal to opposite over hypotenuse. In this case, opposite is labeled as the height, and 3.6. Okay. Now we have to use our algebra skills in solving equations. So I don't want this 3.6 in the denominator, so I'm going to multiply both sides by 3.6. These two 3.6's would cancel to give 1, so now I have h is equal to 3.6 times sine 15 degrees. And if you enter this into your calculator, I believe it gives an approximate measure of 0.93 meters. And again, we should have concluding statements, therefore the height is 0.93 meters. Okay. So this concludes the two examples that I want to do in the video portion of the video. Sorry. What I want you to do for homework or prior to coming to class is, one, if you can make some notes, 2, summarize some of the key points of the video. And 3, if you can come prepared with a question. Make a question or write some questions. It could be anything. Is there something that you want me to clarify once we meet in class? Or anything like that. Okay?